Now on this section, we will go to the next lab, which is managing deployment using Kubernetes engine. So let's click on it. And as always, before jumping or starting the lab, let's go briefly through the tasks. So we will be learning about the deployment of the object. The explain command on kubectl tells us about the deployment. We can also see all of the fields using the recursive option. And you can use the explain command as you go through, help you understand the structure of a deployment. Gotcha. Now, to create a deployment, this is just to get a file. We will start the editor and change the image in the container section for this. Okay, then we just save again this YAML file and press enter. This will be the end file. And to create a deployment, you use kubectl create with the file just edited. To verify it was created, kubectl get deployments. And once deployment is created, Kubernetes will create a replica set for the deployment. We can verify that a replica set was created for our deployment with kubectl get replica set. We should see a replica set with a name like this. And now we use kubectl create to create a service, an authentication service. And the same thing with the hello deployment. This has been done in the previous activities. And one more time, to create and expose the front-end deployment, we run this command. This is how we get the external IP, which we will change in here when we run this. And this is the last command to run. If everything is okay, we should be able to check this. Okay, now task number 2 is about scaling a deployment. Now that we have it created, let's scale it. We will use the specification replica field. Let's see. So we will kubectl explain deployment dot replica spec replicas. The replicas field can be most easily updated using kubectl scale, like this. Okay, takes a few minutes to do it. We will verify to get in the pods if we scale back. And again, to verify everything is correct with kubectl get pods. Good. Now, about rolling updates. Deployments support updating images to a new version through a rolling update mechanism. When a deployment is updated with a new version, it creates a new replica set and slowly increases the number of replicas in the new replica set as it decreases the replicas in the old replica set. So this is what is happening. Replicas 2, replicate 1. And let's trigger a rolling update. To update the deployment, just kubectl edit deployment, the name of it. We will change the image in the container section for this name. Then save and exit. Let's see the new replica set that Kubernetes creates, and we can see the new entry rolled out history. Now to pause a rolling update, this is the command rollout pause. To verify if the state, we run kubectl rollout status, and we can check the pods directly with kubectl get pods and the rest of the command. To resume a rolling update, we got kubectl rollout resume. As well, check again the status. Now let's roll back. If something went back and we want the first version. This is what we do. kubectl rollout. Rollout undo, the name of the deployment, and to roll back in history or check back the history, we get this command. Finally, again, with this we check the pods. Now, our task number 4 is about canary deployments. When you want to test a new deployment in production with a subset of your users, use a canary deployment. Canary deployments allow you to release a change to a small subset of your users to mitigate risk associated with new releases. So create a canary deployment. A canary deployment consists of a separate deployment with your new version and a service that targets both your normal stable deployment as well as your canary deployment. And here we have it. Like, this is the deployment with the app hello, the deployment with the app hello and the track, and this is how it's directed to this one and the other. So, and with this command, we're just creating again this YAML file, which is this. To create the canary deployment, we run kubectl create after deployment and the YAML file we already had. After it is created, we should get 2 deployments, hello and hello canary. That if you run this command, you should be able to see both of them. To verify the canary deployment, just send this command. After that, let's check the progress. Now, our task number 5, the blue-green deployments. Rolling updates are ideal because they allow you to deploy an application slowly with minimal overhead, minimal performance impact, and minimal downtime. There are instances where it is beneficial to modify the load balancers to a point that a new version only after it has been fully deployed. In this case, blue-green deployments are the way to go. Kubernetes Kubernetes achieved this by creating 2 separate deployments, one for the old blue version and one for the green version. Use your existing hello deployment for the blue version. The deployments will be accessed via a service which will act as the router. Once the new green version is up and running, you'll switch over to using that version by updating the service. So we have like the old and the new version, the old version 1, the new version 2. And we have a note. A major downside of blue-green deployment is that you will need to have at least 2x the resources in your cluster necessary to host your application. Make sure you have enough resources in your cluster before deploying both versions of the application at once. So with this, we update the service. And here is the file. We'll create a green deployment. We verified version 1 is still in use. We update the service. The service is updated. The green deployment will be used immediately. And let's go with blue-green. Roll back. If necessary, you can roll back. And this is how you do it. kubectl apply services hello blue. Once you have updated, you can roll back again with this command. And that's it. This is just a brief review of our lab managing deployments using Kubernetes engine. Perfect. Now let's run our lab. So we'll click on the stairs. Oh, let's click on the buses. Let's use our credits. Now we'll open Google Console. We'll copy our username. Let's click use another account. Let's this, we'll click next. For our password, we'll this password, paste password. So I will agree the terms and continue and double check. This is the student account. And let's go. So let's activate Cloud Shell. On the top right corner, click Activate Cloud Shell. We'll continue. To get, this is optional, but I always like to do it. Because in here, I can now authorize Cloud Shell. Here it is. Here is the account, which is currently active. And step 1, let's set the zone. We're setting the zone to US West 1A. Now to get the code for this exercise, we run this command and it will start downloading all these files. The operation is completed. And now let's create a cluster with 3 nodes. And as the note says, it might take a few minutes. Okay, now it's running. Let's go to task number 1. Let's explain. Let's use the explain command on kubectl explain deployment. Let's see what we got here. And let me put this bigger. There's a lot of information here. So this is a group, version 1. These are the fields. And we got all this information. We can also see all fields using the recursive option. Let's use that. See what we got. And yep, if you scroll up, you got all this information. All this is huge. Okay, let's just scroll down again. And you can use the explain command as you go through to help understand the structure of deployment. Let's see. Yep. Now let's create a deployment. If we use this command, it opens this one. To start the editor, we have to press I key. I use I, then you see it changed here to insert, and change the image in the container section for the following, for 1.00. Yep. It was scrolled down. Here we have 200, and we will change it for 100. Now to save it, we will have to press the escape key in your keyboard and this command. So escape, we have WQ and enter. Now let's see. This is the file now. Perfect. Now go ahead and create your deployment using kubectl create. Let's do it. It says deployment is created. Now you have created deployment. You can verify it using this command. Yep, it's there. And once the deployment is created, Kubernetes will create a replica set for the deployment. We can verify that a replica set was created for our deployment with this command. So let's see. Yep, here we have something. AUTH 7F58, and we should see a replica set with the name AUTH and the code. Yep. Finally, we can get pods. They're running. Okay. We saw they were running, and using the kubectl command to create an AUTH service. Let's do that. It says it was created. And now let's do the same for the hello deployment. Oh, it says the connection to your Google Cloud Shell was lost. Let's reconnect. What happened? Let's refresh this. Let's reload. This is the user account. This is the password. Let's open on the shell one more time. Yep, and here we are. So our last command was created in the hello. Let me check. No, the last one was create F services. So let's create this now. Yep, that's created. And let's do this one. Now, interact with the front end by grabbing external IP and then kernel. Let's run this. And we see that we got external IP pending. So it will take a few seconds. And we will run again this command until we get the external IP. Still pending. There it is. Now we will run this, and on the external IP we will delete this part and type it. The one we show your external IP will be different from mine, so just check this number in here. And we get a reply, hello. If we run this, we should also get a same hello message. Now let's scale our deployment. Let's use kubectl explain. Replicas. Now let's run this one. It says, it might take a minute or so for all the new pods to start up. After the deployment is updated, Kubernetes will automatically update the associated replica set and start new pods to make the total number of pods equal 5. verify that there are now 5 hello pods running this command. Let's see, we run this command. There are 5 in here. Now scale back the application with replicas equals 3. Let's copy this. And again, verify that you have the correct number of pods. Now, if we run this, we should get 3. Yep, here we can see it, it's 3. Rolling and update. So, to update your deployment, run the following command: kubectl edit deployment hello. And now we will change within containers the image back to 2.000. Remember, we have to press letter I inside of containers. Scroll down. Instead of 100, now we will have 200. Press the escape key in our keyboard, and now this command and enter. Once you have set out the editor, the updated deployment will be safe, and see the new replica set that Kubernetes create with kubectl get replica set. That's it. Check this out. Get 4. You can also see a new entry in the rollout history. Let's check that. Now, give it a try. If you detect problems with the running rollout, pause it to stop the update. Verify the current state. You can also verify this. Resume a rolling update. This usually takes a bit of time. If you pause and then you resume, if you roll back. So let's jump into task number 4, canary deployments. So let's create this. Let's kubectl create. I just created. Now get the deployment. Here it is. Hello canary. Version 2.0.0. Canary deployment in production. So in this lab, each request sent to the engine service had a chance to be served by the canary deployment. But what if you wanted to ensure that a user didn't get served by the canary deployment? A use case could be that if the UI for an application changed and you don't want to confuse the user in case like this, you want the user to stick to one deployment or the other. You can do this by creating a service with a session affinity. This way, the same user will always be served from the same version. In the example below, a service is the same as before, but a new session affinity field has been added and set to client IP. All clients with the same IP address will have their request sent to the same version of the Hello application. So here we can see the new line added to the code. Due to being difficult to set up an environment and test it, you don't need it here, but you might want to use session affinity for canary deployments in production. Now our last task is number 5, blue-green deployments. Rolling updates are ideal because they allow you to deploy an application slowly with minimal overhead, minimal performance impact, and minimal downtime. There are instances where it is beneficial to modify the load balancers to point to that new version only after it has been fully deployed. In this case, blue-green deployments are the way to go. Kubernetes achieved this by creating two separate deployments, one for the blue version, and one for the green version. So here we can see the old is 1.0, the new is 2.0, one is blue, this is green. Keep in mind that you will need 2 times the quantity of resources for running this at the same time. So let's get our hands on the code. First, let's update service. Note, ignore the warning that says resource service hello is missing, as this is patched automatically. Okay, good to know because yep. Now create the green deployment. So create it. Now once the green deployment and it is start, probably verify that the current version is 1.0.0. Let's see. Oh, we have version 2.0.0. Now update the service to point to the new version. When the service is updated, the grid deployment will be used immediately. You can now verify that the new version is always used. So blue, green, rollback. Gotcha. This is basically doing the rollback and updating, and this is the same for the version. And well, that's it. This is how we finish our lab, and thank you very much for this.